Imagine a world where everything is reversed. Up is down, left is right, and matter is antimatter. Sounds like something out of science fiction, right? Well, antimatter is very real, and it's stranger than fiction. It's the mirror image of ordinary matter, and it holds unimaginable power. Antimatter has fascinated scientists and the public alike for decades. It's a key to unlocking some of the universe's biggest mysteries, like the Big Bang and the nature of dark matter. But antimatter isn't just a theoretical curiosity, it has the potential to revolutionize our technology and propel us into a new era of scientific advancement. Imagine spaceships traveling at near-light speeds, powered by the most efficient energy source imaginable. Picture medical breakthroughs, treating diseases with incredible precision. This is the promise of antimatter, a realm where science fiction and reality collide. To understand antimatter, we need to take a peek inside the atom. Everything around us, from the air we breathe to the stars in the sky, is made of atoms. Atoms are like tiny building blocks, and each block has even tinier particles inside. Two of these particles are important for our story: protons and electrons. Protons live in the atom's center, the nucleus. They have a positive electric charge. Electrons, much lighter, whiz around the nucleus. They have a negative charge. Now imagine those charges flipped. That's antimatter. An antiproton is just like a proton, but with a negative charge. A positron is like an electron, but with a positive charge. Antimatter isn't some exotic substance found on distant planets. It can be created right here on Earth in particle accelerators. These giant machines smash atoms together at incredible speeds. Sometimes these collisions produce tiny amounts of antimatter. Antimatter might seem like something out of Star Trek, but it already plays a role in our lives. One of its most well-known uses is in medicine, specifically in a technique called positron emission tomography, or PET scans. In a PET scan, a small amount of a radioactive substance that emits positrons is injected into the body. When these positrons encounter electrons in our tissues, they annihilate each other, releasing energy in the form of gamma rays. These gamma rays are then detected by a scanner, which creates detailed images of our organs and tissues. PET scans are invaluable for diagnosing a wide range of conditions, from cancer to heart disease to Alzheimer's disease. They allow doctors to see inside the body and monitor the function of different organs with remarkable precision. Antimatter research is also advancing our understanding of fundamental physics. By studying how antimatter particles interact with each other and with matter, scientists hope to unravel some of the deepest mysteries of the universe, such as the nature of dark matter and the origin of the universe itself. Creating antimatter is one thing, but storing it is a whole other challenge. Remember, when matter and antimatter meet, they annihilate each other in a burst of energy. This means we can't just store antimatter in a regular container. Scientists have devised ingenious methods to trap antimatter and prevent it from coming into contact with matter. One method involves using magnetic fields. Antimatter particles, like positrons and antiprotons, have a property called charge. This charge makes them behave like tiny magnets. By creating strong magnetic fields, scientists can confine antimatter particles and suspend them in a vacuum, preventing them from touching the container walls. This is similar to how magnets can levitate objects without them touching. Another method involves using extremely low temperatures. At extremely low temperatures, close to absolute zero, antimatter particles move much more slowly. This makes them easier to trap and contain. Section 5. Antimatter, propulsion rockets to the stars. Imagine a spaceship traveling at a significant fraction of the speed of light. Such a vessel could reach nearby stars within a human lifetime, making interstellar travel a real possibility. Antimatter propulsion could be the key to unlocking this dream. When matter and antimatter annihilate, they release an incredible amount of energy, far greater than any chemical reaction. This energy could be harnessed to propel a spacecraft forward at tremendous speeds. In theory, an antimatter-powered rocket could achieve speeds approaching the speed of light, allowing us to explore the cosmos like never before. Of course, there are significant engineering challenges to overcome before antimatter propulsion becomes a reality. One of the biggest challenges is producing and storing enough antimatter. Current production methods are extremely inefficient and expensive. We would need to develop new technologies to create and store large quantities of antimatter for interstellar travel. Section 6. Antimatter energy powering the future. The energy crisis is one of the most pressing challenges facing humanity today. As the global population continues to grow, so too does our demand for energy. Antimatter could provide a solution to this energy crisis. Antimatter is the most energy-dense substance known to exist. A single gram of antimatter contains as much energy as a nuclear bomb. If we could harness this energy safely and efficiently, we could power our cities and industries for centuries to come. Antimatter power plants would be incredibly efficient and produce virtually no pollution. Unlike traditional power plants which release harmful greenhouse gases, antimatter power plants would produce only energy and harmless byproducts. Of course, antimatter energy faces significant hurdles. The biggest challenge is the cost and difficulty of producing and storing large quantities of antimatter. However, with continued research and development, antimatter could become a viable energy source in the future. Section 7. Medical Marvels, Antimatter and Healthcare. We've already seen how antimatter is used in PET scans, but its potential in medicine extends far beyond diagnostics. Antimatter could revolutionize the way we treat diseases like cancer. One promising area of research is antiproton therapy. Antiprotons, the antimatter counterparts of protons, can be used to target and destroy cancer cells with incredible precision. When an antiproton collides with a proton in a cancer cell, they annihilate each other, releasing a burst of energy that kills the cell. Antiproton therapy has several advantages over traditional radiation therapy. First, antiprotons deposit their energy more locally, minimizing damage to surrounding healthy tissues. Second, antiprotons are more effective at killing cancer cells, potentially leading to shorter treatment times and fewer side effects. Antimatter could also be used to develop new imaging techniques, allowing doctors to see inside the body with even greater detail and precision. This would enable earlier diagnoses and more effective treatments for a wide range of diseases. Section 8. Challenges and Risks. The duality of antimatter. While the potential benefits of antimatter are undeniable, it's important to acknowledge the challenges and risks associated with this powerful substance. Antimatter is often described as the most dangerous substance in the universe, and for good reason. The annihilation of matter and antimatter releases a tremendous amount of energy, far more than any other known process. If even a small amount of antimatter were to come into contact with matter, it would result in a catastrophic explosion. Storing and handling antimatter safely is a monumental challenge. It requires sophisticated containment systems and meticulous safety protocols to prevent accidental annihilation. The high cost of producing and storing antimatter is another major hurdle. Ethical considerations also surround the development of antimatter technologies. The potential for misuse, particularly in the development of weapons, is a serious concern. Section 9. Antimatter Ethics, a universe of responsibility. With great power comes great responsibility. This adage rings especially true when it comes to antimatter. As we venture further into the realm of antimatter research and development, it's crucial to establish ethical guidelines and safeguards. The potential for misuse of antimatter is a serious concern. In the wrong hands, antimatter could be used to create incredibly destructive weapons, far more powerful than any existing weapon system. International cooperation and strict regulations are essential to prevent the weaponization of antimatter. Another ethical consideration is the allocation of resources. Antimatter research is expensive, and some argue that these resources could be better spent addressing more immediate global challenges, such as poverty, hunger, and climate change. It's important to strike a balance between pursuing scientific advancement and addressing the needs of humanity. Open dialogue, transparency, and public engagement are crucial for ensuring the responsible development of antimatter technologies. Section 10. A future forged in antimatter. Imagine a future where spaceships ply the stars powered by antimatter engines. Cities gleam with the clean energy of antimatter power plants. Diseases like cancer are eradicated with antimatter therapies. This is the promise of antimatter, a future where science fiction becomes reality. The journey towards an antimatter-powered future will be long and challenging. It will require groundbreaking scientific discoveries, innovative engineering solutions, and careful ethical considerations. But the potential rewards are too great to ignore. Antimatter has the power to transform our world in ways we can only begin to imagine. It could solve our energy crisis, enable interstellar travel, revolutionize medicine, and unlock the deepest secrets of the universe. The future is uncertain, but one thing is clear. Antimatter will play a pivotal role in shaping the destiny of humanity. Section 11. Antimatter, the next giant leap. Antimatter is a paradox, a universe in reverse. It is both incredibly destructive and potentially life-saving, a source of both great risk and even greater promise. As we continue to unlock the secrets of this enigmatic substance, we embark on a journey into the unknown. The study of antimatter is a testament to the power of human curiosity, our relentless drive to explore the universe and understand our place within it. It is a journey that will challenge our assumptions, push the boundaries of our knowledge, and inspire generations to come. Antimatter is more than just a scientific curiosity, it is a key to unlocking the future. It is a future of clean energy, interstellar travel, and medical miracles. It is a future that we can only create together, through collaboration, innovation, and a shared commitment to responsible exploration. Let the journey begin.